Even though there's a lot of hype going around, there are a lot of places where AI simply falls short when it comes to coding or programming in general. And in this video, I want to share those points with you where I think that it simply is not able to do things in the correct way and help us build good code bases that are able to not only deliver features to users, but also be modified over time. Like I just said, there's a lot of hype going around. There are a lot of people on X Twitter especially hyping this thing to the moon, and I think that allows us and makes us not really talk about or think about these points where the AI falls short, and this will actually lead us to a better usage of AI coding agents instead of just trying to think that they're perfect, everything they do is perfect, and do stuff like the creator of OpenClaw, which says that he doesn't even read the code anymore, which I think is a mistake. So let's go over the different points, and if you've already been programming with AI coding agents, you'll see that this is going to sound very, very familiar to you. If you want to learn more about using AI agents for software engineering, go to techwithtourist.com/AI. I'll be releasing a live training class next month on how to do AI-driven development. If you're a vibe coder, this is not for you. Instead, it's all about building systems and code bases that help you scale AI agents for software engineering. We'll focus on how to plan, execute, and verify, and how this loop creates an environment that leads to AI agents writing code and features exactly how you want, instead of just hoping for the best. Again, go to techwithtourist.com/AI to save your spot for next month. The first point is that it optimizes too early. We have here an example of a file path, which is a path to the file we know is very small. We're just trying to build a project from the ground up, and we know this file has, let's say, 100 lines, 200 lines, something that is very easy for our local machine to read and process, so we don't need to optimize it yet, or maybe ever in the future, because this file will always stay small, so there's no real point to doing that. But usually what happens is that the AI, when we tell it, okay, implement a function that is going to read this file, more likely than not is going to overcomplicate things and optimize things too early. So it doesn't really have this concept of building things from the ground up and figuring out things along the way because of its training data. Training data has a lot of examples with just like very complete quote unquote code, which makes a lot of sense to be used in certain contexts, but in other contexts it doesn't really make sense. And the AI doesn't really know that. It doesn't know that, okay, this is still a very green code base, a very young code base, so we want to avoid creating a lot of optimizations that waste our time and overcomplicate the code base. So it will end up doing things like avoiding reading the entire file into memory and read the file in chunks, for example, to avoid too much memory usage. And I think this is a example of where this happens, but like I said, if you've been using AI coding agents for a while, you know that this is a recurring pattern where we have to steer the AI agent into a place where we tell it, okay, I want you to not complicate this so much, I don't want you to optimize this, I want you to just keep this implementation to its bare bones, to the simplest implementation possible, and even there it is still going to try and do things that don't really make sense in the current context of the project we're building. I'm going to repeat this because I think it is very important. I'm not saying that these things are not useful in certain contexts, but in a lot of contexts they're simply not, and we end up creating so much complexity in a code base from the get-go when there's really no need, especially when we haven't even figured out the API, how the structure of the project should look like, or what we really want to do, and then we can maybe start getting into these optimizations. But I think this is the first point where this falls short because of, again, its training data. It is true that we can use some kind of prompting technique to steer the model into a different place, but at that point we're sort of like going against what the instinct quote unquote of the model is because of its training data. So I think this is a point where the AI coding agents simply produce very poor code as a result. The next one is that it is too defensive in its programming, and this is not true for all models. It is true for some models more than others. I would say Codex, GPT 5.2 Codex is the worst when it comes to this. Gemini might be the best one, which like the model usually doesn't do this a lot, but it still does to a certain degree. And I think that this again leads to very poor code bases and also a lot of frustration. So again, an example with reading the file that I can give you is that we have a path to a file that we know exists, and more than that, we have this as a constant. So this is not something that we're fetching from, let's say, a CLI arguments. So we parse the CLI and then we see if the file exists or not. We're sure it exists. We are in like this mode of trying to figure things out inside of a project, and we don't really want to like steer away from our goal inside of our current project. And what happens is that we tell again the AI coding agent, hey, I want you to go and implement this file or this function, I should say, that reads a file, and then the model is going to do like silly things that like this. For example, if the file path is different than an empty string, then we can read it. And we already know here inside of the file that it is an empty string. It is not rather an empty string. And because again of its training data, it ends up doing a lot of these silly mistakes that like in the context of the thing that we're building just don't make any sense. In its training data, it has seen a lot of times that when we want to read a file, we need to check if the path actually exists. If it is not a empty file, maybe here it would even add something like with Node.js to check if the file actually exists or not in the file system, even though again inside of this project we are pretty sure that it exists. We're just like trying to figure things out for the moment, and this is not yet at a production level situation. Even if it is a project that is already in production, we're maybe still building this part of the product, this feature specifically, and it doesn't make sense at this point to waste like 15 minutes, 30 minutes, 1 hour just trying to build something more complex just because again it wants to do a lot of defensive programming where just doesn't make really any sense. So here what I would do would be simply like define here the constant and then just read the file, because I'm here, I'm inside of my local machine, I know the file is there, I'm just trying to build things gradually along the way instead of adding like all of these checks, all of these optimizations and this kind of defensive programming that doesn't make any sense in the current context. The next point is sort of a combination of the previous 2 points, which is it jumps straight into complexity. So not only does it do the previous 2 things that I've mentioned like separately, sometimes it sometimes combines these 2 together and even more stuff, like it piles on a lot of different stuff in terms of complexity, and we just end up with something that could have been between 10 to 20 lines of code, and it becomes a mess of like 200, 300, 400 lines of code. And this is also why I think that this metric that is currently going around of lines of code being something good, being something that we should strive for, is just silly. Obviously, if you use AI agents and you don't steer them in the right direction, you're going to end up with all of these patterns being implemented from the get-go, and then obviously you'll be able to like pump out 20,000 lines of code in one day because a simple function that should just read a file that we know exists, we know like we already have the path to it, we know everything about it, it becomes like this convoluted mess that doesn't have to be that way, but it becomes 1,000 lines of code, for example, and we then cheer ourselves and say, okay, I've like added 1,000 lines of code to this code base, this is so great, AI is amazing, when in reality that function didn't even need to have so much complexity in the first place, and it just like steers us into this wrong direction of thinking that adding more complexity, adding more stuff means a better code base, when a lot of the times, and I would say most of the times, simplicity is actually better, especially in certain kinds of contexts, like I said, where we're still figuring things out, and then we want to obviously add some of these defensive like programming strategies, implement things in a bit more like in a way that is a bit more performant, but we don't want to do that in all contexts. It is again silly to think that one pattern, one way of doing things applies to everything across the board, and that is usually what the AI agents tend to do, again because of their nature, because of the nature of an LLM, because of their training data. They don't have this ability to just say, okay, in this context, should I actually implement something so complex or not? We again can steer it into a different direction using like plan mode, using strategies for prompting, but that is just more work that we are doing to again steer it from its quote-unquote natural like behavior way of implementing things. And the final one, which is probably the most annoying one that I usually encounter, is that it doesn't usually understand context or intent. The reality is that sometimes it does, sometimes it doesn't, but it does this thing that I think is very, very like annoying, where for example it implements something, and like I just told you, it implements something with a lot of complexity, and then I go to the model and I tell it, okay, remove the chunking when reading the file, it is not necessary. So this would be sort of like the prompt that I sent the model, and then the result would be something like that. It would go from this thing here where it avoids reading the file into memory and it reads in chunks, to something like this. It explicitly says read file without chunking, which is something again very annoying, because usually when I say to the model we don't want this in the code base, the model goes to the code base, it adjusts things, but it leaves these comments and trails behind to mention that we've removed this thing that we didn't even want in the first place, which is again very clear here that the model simply doesn't understand the context or the intent. If I tell it we don't want to read this in chunks, it should simply remove that part of the implementation and leave no trace behind that we didn't like, that we even did that in the first place, which is again something very annoying to me. And this happens all over the place, not only in this example. When I'm talking, for example, about documentation, if I am building documentation with an AI agent, I tell it, okay, you need to adjust this line to not use, for example, Git anymore. I'm just like throwing a random example, and it goes there and says the title or the subtitle of this part of the documentation, and then it puts into parentheses without Git, for example, which is again very annoying because it doesn't understand, hey, we don't want this thing in the code base, we don't want this thing in the documentation, please remove it. Doesn't mean that we need to leave like a trace behind. And then I realized that if we're not careful, in my case, it just grows into this mess where we have a lot of like small things across the entire code base or across different files, mentioning things that like don't make any sense because we're not really using them, but then it still mentions that, which is like very annoying. We have like this thing without this, or this doesn't implement this in this way, this doesn't implement that in that way, and it just like is very, very annoying. So one thing that it also does, like I said, is add something like this comment that says files should not be read in chunks, which again, like we don't need to like specify things in the negative aspect, like say what we don't want to do each time that we don't want to do that. Again, something very just annoying, and this sort of just pollutes the entire code base, pollutes the entire documentation, and just creates a lot of confusion and mess inside of the code base, because then the model is going to like, not only is the model going to be like lost with all of these little comments all over the place that says without this or without that, or don't do this, don't do that, but it also going to confuse us a lot, because it's going to be a lot of like trash or litter all over the like the code base. So yeah, this is it. I think that these are the main points that I think AI really falls short at when it comes to programming and coding, and I really think that we still need to be able to read the code base, to still implement things manually, to still create patterns before we give some kind of task to the LLM, instead of just like leaving the LLM alone and letting it do its own thing, which I think is a big mistake and a silly mistake overall. I just told you the creator of OpenClaw said that he doesn't even read the code anymore and he just trusts the code, and then obviously that is going to lead to a lot of problems, because these LLMs are still not at a point where we can let them do that. And I think again, it's just a matter of hype, of wanting to make other programmers believe that that is the case, when it's simply just not the case at all. And I think that we should still again pay attention to a code base, use these tools in a way that is actually productive for us, instead of trying to grab a tool and try to fit the tool into like our workflow in a way that is not natural, in a way where the tool is simply not there yet. Is going to lead to again a lot of problems, instead of saying, okay, we have this amazing tool, AI coding agents, they're very useful for some things, not useful for others, and we need to know where that line is and be able to use it in the correct way. So this is it. I hope this video was helpful to you. Let me know in the comments below what you think of it, and I'll see you on the next one.